All right, guys, let's do a little bit and start. I said you had to get to 18. Let's work at 18 and work our way back. Okay, 18. All these word problems they start somewhere and they either go up or down. So what I have, it looks like a science teacher is planning a field trip to either the aquarium or the science center. The aquarium charges $80 for a class tour guide. So $80 just because. That's where we start. And then also $12 every single student. So there's our slope, $12 every student. All right, so at the end it says write a system of two equations where each equation models the total cost. We're gonna use Y and we're gonna use X. Okay, here we go. Enter one equation per box. All right, so we have two equations. They don't even need us to solve. They just want us to write the equations. Okay, so let's see. For the aquarium, Y equals, where do we start? We start, just to show up, it's $80 just to get the tour guide. So $80 just because. And then on top of that, we're going to have to, our cost is going to go up $12 for every student. There we go. All right, the Science Center charges $15 per student. Every student, $15 per student. And it has a class lab fee of $60. So just because you want to show up, we're going to charge you $60. That's kind of like the entry fee, the lab fee. All right, so for this guy, $60 just because. $60, that's the lab fee. The $15 per student, every student. $15 every student. There we go. There's our two equations. Let's see. This one. These are the same thing. This shape was created by 90 degrees rotation sideways. Okay, 90 degrees rotation. Okay, let's see. I just want to make sure this, I kind of can't tell these guys apart. I mean, I sort of could, but let's just say it's obvious that this guy is this side over here, right? If I just rotate, they're exactly the same size shape. So that means if this is just rotating, this guy rotates to there, this guy rotates to there. Okay, no big deal. So the LM side is Y. Okay. Oops, I didn't mean to put, just like the Y is the LM side. So let's put a check there. Okay, let's see. Where is this point right here? I'll put it in pink. Let's see, this point is at 7, -2. That means if it rotates 90 degrees, it's gonna switch the numbers, so 2, 7, and it's going to end up in Sussman's neighborhood, so it's going to end up -2, -7. So let's see. That's this spot. -2, -7 is right there. Uh-oh, somebody's calling me on my phone. Amber Alert. Ew. That's not good. Okay, -2, -7 is right there. So this is where this point is. So that must mean this is Z over here, and this is X over here. So that's the way this guy moved. So if that's the short side and this guy went to here, then this guy must be there. This guy rotated all the way to there. Okay, so let's see. X is the MN side, and Z rotates to the side between L and N. There we go. All right, 16. Let's see. Which one of these is 3x plus 4? Okay, if they give me already the answer, I'm just going to try out. Which one of them can I take my x and multiply by 3 and then add 4? So let's see. I'm going to choose some numbers. Let's see. I'll choose 1. 1 times 3 is 3. Plus 4 is 7. This should be 7, not 8. So no, this one's out. Let's try this one. 4. I bet that was supposed to be, 4 times 3 is 12 plus 4. This is supposed to be 16. No, that's wrong. Let's try 6. Let's try 6. And you're gonna all of them need to be right for it to be the right one. Let's see, 6 times 3 is 18 plus 4, get out of there, plus 4 is 22. This should be 22, not 7. By process of elimination, I can already tell this is the one. D is the one. But let's see. If I do, let's try 5. 5 times 3, 15, plus 4, 19. Oh yeah, it does work for this one. 10 times 3 is 30, plus 4 is 34. Oh, it is this one. Yeah, so I'm just checking the answer. Normally they don't give us the answer yet, and I make you guys do like, oh, this goes up 15, this goes over 5. The answer is, and here's the begin on blue number. But if they give you it, we're just checking. 15, a squared, b squared, c squared. Let's see, a squared plus b squared equals c squared. And remember, the a and the b are the straight up and sideways ones. So 6 times itself twice plus 10 times itself twice equals some number times itself twice. Let's see, 6, that's 36 plus 100 equals, I don't know, squared. 136 equals, I don't know, squared. So we take the square root to get rid of the squared. And c equals the square root of 136. That's something I don't know. I'm going to put in my calculator. I'm going to put 136, and I'm going to hit the square root button. And it looks like I get 11.66. I'm going to round it to the nearest tenth. So this 6 makes that 6 go up to 7, 11.7. All right, let's go to 14. All right, 14. Depending on if you understand these or not, let's try, this is my x, this is my y. What if I plug in 1 for x and 0 for y? Does that work? If you don't know how to do these, you can plug this in. So 8, instead of 8 times x, let's go 8 times x is 1, right? Down here, x is 1. Plus 16 times 0 for y. Does that equal 10? Let's see. 8 plus 0 equals 10? No, it does not. So this is not an answer. All right, let's try 5 for the x and 5 for the y. Is 4, I'll try it in here, 4 times 5, I can try it any equation, it should work in both. Times 8 times 5 equal 5? No, 20 plus 40 does not equal 5. Boom, not that one. All right, let's see. Eeny, meeny, miny, catch a tiger by its tail, if you let him go. Eeny, meeny, miny, mo, infinite solutions. So you could do that. You could try to see if it's one of the two. If it's not, pick one of the two that you don't know. But if you want to know how to do the actual math, we need one of these columns to cancel it out. So I'm going to make this one twice as big. I'm going to make this whole thing twice as big. So instead of 4x's, we have 8x's. Instead of 8y's, we have 16y's. Instead of 5, we have 10. All right. But they're the same equation. Wait a second. So really, they're the same equation. So of course they're always going to be infinity solutions. They're the same equation. But let's say I wanted to make this -2 so that it's 8 versus -8, 16 versus -16, 10 versus -10. So when I add them together, I get 8 versus -8 is 0. 16 versus -16, still 0. 10 versus -10, 0. And we end up with 0 equals 0, which is there are infinitely many solutions. So if you know how to do the elimination, do it that way. Multiply everything by -2 in the bottom one. If you don't, plug in some numbers, see if it works. Test their answers. Try to beat the system. Number 13, make your teams. This should be easy. Make your teams. Make your teams. Make your teams. Make your teams. Okay, really, if I have -7x's and 4x's on this side, -7 versus 4, I really have -3x's on this side. Plus 30 equals 90. I'm going to minus 30 to send him over here with his friend. -3x equals 60. Divide by -3, divide by -3 kills x equals. On my calculator, 60 divided by 3 is 20. And I have this one negative that didn't have another negative to cancel it off. So it lived. -20 is the answer. All right, let's go down to number 12. All right, this one is a process of elimination. Let's try D. What happens if I start with A and I reflect it across the y-axis? Here's the mirror, right? There's the mirror. So let's make a reflection. If this corner is right on the mirror, then its reflection is going to be right on the mirror. If this guy is like 3 spots away from the mirror, then his reflection is going to be like 3 spots away from the mirror. Same thing with this guy. So if I reflect it across the y-axis, he goes to here, not to here. So it's not that guy. If I reflect it across the x-axis, and x is the mirror, there's the... Oh my gosh, I just did it completely backwards. What an idiot. That was reflecting across the x-axis. I thought I was doing that the whole time. Okay, so it's not this one, my bad. If I reflect it across the y-axis, this is the y-axis. My bad, I think I just misspoke. Okay, how far is this guy away from the mirror? About that far, about 2 and a little bit. So he would go to there. This guy would go to about there. This guy would go that far away, he'd be down here. So this guy would reflect to there. So it's not here. So I know it's none of those. I don't know what rotating around a point means. We haven't done that. So eeny, meeny, miny, mo, catch a tiger by the toe. If he holds, let him go. Eeny, meeny, miny, mo. Okay, and I guessed that one, and guess what? I got it wrong. But it is A. Here's why. When they say rotate around a point, 0, 3, if this makes sense to you, we've just been rotating around the middle. If they want to try to rotate around the point, you make that the new middle. So 0, 3 is right here. And now let's draw lines like that's the middle. So we would have the up and down going through there. We would have the sideways going through there. And if that's the middle, does it look like we rotated 2 neighborhoods? 1, 2, yeah, that's what we did. We rotated, it's just that's the point they wanted to be the middle. So I draw it like that's the middle, and then it actually works. So that's not going to be the answer on the test because we haven't done that this year. My point is, if the things that you know don't work, guess on one of the other 2. I guessed B, it was wrong. So, tough question. 11. All right. Imagine this question, 5x squared. Imagine that squared wasn't there. What would that equation look like? That would be y equals 5x plus 6. We can graph that. That would look like this. It would start at 6, 1, 2, 3, 4, 5, 6. It would start right there. It would go up 5 over 1, so there'd be up 5 over 1, up 5 over 1, up 5 over 1, and the graph would just look like that. The graph would look like that. Okay, what happens as soon as we put this to the second power by the x? Well, the graph changes to this. It would still start at 6, but now it would do this, which is something we haven't done unless you're in my honors class. The graph moves like this. Remember some of those graphs I give you on is it a function or not? That's what the equation looks like. So it's still a function because I can do my test and it works. So it's still a function. It's just not a linear function. So what makes something a linear function? Line. It's a straight line. So the reason why this is not a linear function, it's not a straight line. Anytime you put a powers in the equation with the x, it makes a curvy graph. So no straight lines. You would, if you get that right and you draw this, make sure you draw this to let me know you actually watched the video. All right, let's get down to number 10. If you're done, you can stop watching the video because I don't know what number you got up to in class. So depending on what number, you can shut the video off. Okay, this one, 0b, where does this thing start at? It starts at 450. That's what we're supposed to put, just fill in the b. What's the slope? I can trust this guy right there. Okay, so how much does it actually go down? Not one box. It goes from 450 down to 400. That's 50, so it goes down 50. How much does it go over? 2 boxes? Can I say 2 boxes? No, I can't. This is actually 4. Okay, down 50 over 4. If you are good at reducing, you know that these are both even, so I cut them in half. 25 halves, and that is the answer. If you write this in the black box, that is the right answer, but it will be marked wrong because it's not reduced. So what can I do? If I don't trust my reducing skills, I can just put this in a calculator. If I could find my stupid calculator. Okay, 50, oops, nope, clear. 50 divided by 4. That's what a fraction of 50/4 is, right? 50 divided by 4 is 50 divided by 4. And when I hit equal, I can give that equals 12.5. Now the whole thing is still negative, and that would be considered correct. You can give either the fraction, the correct fraction, or the decimal, but you cannot give the wrong fraction. You have to reduce it. So if you're good at reducing, reduce it. If you're not good at reducing, put it in a calculator and tell me that the slope is either negative 12.5 or negative 25 divided by 2, 25 halves. But if you put negative 50/4, the computer will mark it wrong. So if you trust yourself, reduce. If you don't trust yourself, calculator. All right, this question, horrible question. Horrible, horrible question. The only thing they're doing on this one, they said, hey, what is this equation? This one starts at 3. So I say y equals something plus 3. That's where we start. And it goes, I can trust that point right there too. So it goes up 1 over 4. And I can count boxes because all these are just worth 1. So it goes up 1 over 4. And it is going up. So up 1 over 4 all the time. And there's my equation. The only thing I don't understand why they did, in math, 3 plus 2 is the same thing as 2 plus 3. You're allowed to switch the order. So can I switch the order of these guys? I can. It's just not the way we do it, but I can. And why are they switching the order on this one after a year of telling you to write it like the top one? I have no idea. I have no idea. So there's the equation. I think they just want you to know that the slope always goes by the x, whether it's in the front or the back. And the number that's all by itself, whether it's in the front or the back, is where the graph starts. So who knows why they did that? Number 8. If all I do is rotate, everything should stay the same. Is the old angle n the same? Like if it was 40 degrees, is the new angle n still 40 degrees? Yes, true. This is weird. Side LM, that side right there, is the same side as the new LN? Why would two different sides, those aren't the same side. The red side came from this black side. The green side moves to this pink side. They're trying to confuse me. No, that is wrong. Those are two different sides. They're not even talking about the same side. Is the old side M longer than the new side M? No, they're exactly the same. Side MN, that would be, let's find new colors. Is this, I shouldn't put yellow side the same side as this light blue side? Yeah, they're the same. All right, I think I've taken care of all the problems. So if you were paying attention in class, you should be able to get all those. But there's a screenshot, so hopefully it makes sense to you. Okay, make sure your 18 are done. Bye.